Okay, so I gave you these couple problems to warm up on, and I know some of you might not be done with them yet, but let's just kind of go through what to do with them. So start off over here, 7,446 divided by 34. What would we do first? Okay, does 34 go into 7? No, so then what do we do? So we keep going. Yep, we can leave it blank or put a 0 over the top of the 7. Yep. So does 34 go into 74? Yeah, how many times? Twice. So we're going to put a 2 over the 4. It goes over the 4 because that's the last digit that we used. So then what? Now we're taking that 34 and multiplying it back by 2, because remember what that's saying is, especially since that's in the hundreds place, what we're doing is we're subtracting that 34 200 times. So put a 68 there. And remember, there's really zeros here. That's really 6,800, but we're leaving them out to keep it brief. So 74 minus 68 is 6. Then what do we do? So we drop the 4. In some places, you just drop the 4. Some books will teach you to drop the rest of the number. It really doesn't matter. What you have to do is you keep track that that 4 comes from that tens place, so that our next number is going to go above that 4, go up in the tens place here. So now does 34 go into 64? Yes, how many times? Once. So then 34 times 1, of course, is only 34. We subtract that to get 30. Perfect. Then what? Now we can bring down the 6. And either we're bringing it down from all the way up here, or if we dropped it before, we're bringing it down from there, either one. Again, the important part is we know that 6 is from the ones place, so our next number goes in the ones place. Does 34 go into 306? 9 times. 34 times 9 actually ends up being exactly 306. So we have 0 left over. So 7,446 divided by 34 is 219. How many of you had that? How many of you used a calculator? Good deal. Okay, so now for the 47 times 28, where do we start? We're going to start with the 8, so we're going to do 8 times 7, which is 56. Now we can't write that whole thing in, so what are we going to do? 6 and carry the 5. Good. 8 times 4, 32 plus 5 is 37. So it's the 7, and we carry over the 3. Then what? We have to put a 0 over here before we move over to the 2. Then it's 2 times 7 is 14. So 4. Now when I carry the 1, I usually put a line across here. That way I know that whatever's above the line is something new. I just carried new, so I don't confuse whether it's the 1 or the 5. So now 2 times 4 is 8, plus 1 is 9. So there's nothing left to multiply. So we're going to add 6 and 0, 6, 7 and 4, 1. So 1 carry the 1. 1 and 3 is 4 plus 9, 13. So 3 carry the 1. So 1,316. Now again, I realize that most of you are not going to do a lot of long multiplication and division by hand. So if I'm looking at this, I'm saying this is about 50. 47 would be close to 50. 28 would be close to 30. 3 times 5 is 15, and I put 2 zeros after. When we're multiplying, we combine the zeros. So I'm expecting an answer close to 1,500. Calculator spits out 1316. That's in the ballpark. Over here, I'd probably say that this is about 7,000. This is about 30. Well, it's not going to divide out real closely, but 7 divided by 3, even though it doesn't come out exactly, it's about what? 2. 6 divided by 3 would be 2, so 7 divided by 3 is a little bit bigger than 2. What do we do with the zeros? There's 1 here that we're dividing by, so we're going to cancel out 1 up there. We're left with 2 zeros. So we're expecting an answer close to 200. A little bit larger than 200 because 7 divided by 3 is a little larger than 2. Okay, well, any other questions on the homework or that you want me to go over? Any of the processes? If you're struggling with doing the calculations by hand, use the calculator if you need to, but make sure you're working on your basic facts. I would not expect you to look at 47 times 28 and know that that's 1,316. But I would expect you to be able to take 47 and say it's close to 50, the 28 close to 30, and get that to be 1,500 without using a calculator. And as long as you can do that much right now on your own without a calculator, I'm okay with that. Because I realize the calculators are there, they're a tool. But make sure you can get that close estimate on your own. No questions? Anything you want me to go over? Okay. Yes.
Yeah, those questions on the joist.
Okay.
That's what I'm talking about.
Yep.
I was strictly doing the math and not thinking about the practical end of it.
Sure.
And I looked at the answer and I noticed I was one off. And after I thought about it, I understood you don't count
Sure.
the first one.
Yep, and that's actually a very good question. That's one of the things I was going to bring up if nobody asked it. If you're looking at joists going across a 12-foot run, of course you have the span and you have the run. That would mean the joists are going this way. And I want to put these in as a 2-foot on center. That just means the joists are spaced 2 feet apart. To figure out how many joists are required, joists or even studs or anything where they're spaced evenly like that. Pretty obvious that we're dividing, that we're going to take the 12 feet divided by 2 feet. Now, as we mentioned the other day, when we do multiplication and division, we also combine the names. So that feet is actually kind of important here. What is 12 divided by 2? 6. Feet divided by feet, it divides out. It cancels out, right? Just like x divided by x would cancel out if this were algebraic numbers. So 6 is a pure number. It means we have 6 of something. The problem is when we do that division, we get the first one, we get 1, 2, 3, 4, 5, 6. It accounts for all of those joists, but it doesn't account for the one here at 0 feet. So whenever we do a calculation like that, we do have, like you said, we have to add 1. So it's going to take 7 joists to go across there. Now the other side of that, there are some applications where you don't want anything at either end. For example, if you have a bundle of lumber that's going to be, let's say it's a 18-foot bundle of lumber and it's going to be strapped every 3 feet. So we've got what, 3, 6, 9, 12, and 15. If you were going to take 18, and again you could do the feet, divided by 3 feet, the feet cancel out and you get 6 again. But do we need 6 straps? No, because you don't put a strap on either end. So in that case, you'd subtract 1 from it to get the number we need. We need 5 straps there. So when you're dealing with a calculation like that where you have evenly spaced items, you have to ask yourself, do I need 1 on each end or not? If I need 1 on each end, like with the joists, where you have to have 1 on each end, then you're going to have to add 1. If you don't need 1 on each end, if both ends are going to be empty, then you have to subtract 1, like with the straps. So that's a question that a lot of people do miss until they get used to it, is evenly spaced items like that.
Another question.
Yes, sir.
I know it didn't affect the answers that we gave, but what exactly is a board foot?
A board foot?
Yeah, I don't
Okay.
know. Does anybody use that term?
Yes, actually you do. It depends on how you purchase your lumber. Nowadays, most lumber is purchased by the linear foot or by a mill, which is 1,000 linear feet. But if you're going to buy directly from a sawmill or anything like that, you'd be working with board feet. A board foot is just a unit. If you have a piece of lumber that is 1 inch thick and 12 inches in width, a board foot is 1 foot of length. In other words, 12 inches of length. So it's 12 inches by 12 inches by 1 inch. and it actually gets converted down to 144 square inches of cross-sectional area for a foot of length. Or again, 12 inches of length. Or not 144, 12 inches. It's 144 cubic inches is a board foot. It's 12 inches of square cross-sectional area for 1 foot of length. So it doesn't have to be a 1 by 12, it can be a 2 by 6. Now obviously, if you guys work with lumber at all, you know the 2 by 6 isn't actually 2 by 6 anymore. But that's rough cut. They get planed down to 1.5 by 5.5. And we will actually at some point this semester talk about board feet and lumber pricing and stuff like that for a while. So we'll go through that in a lot more detail. There's actually conversion factors from board foot to linear foot and stuff like that. There's actually some, it's very useful applications of board feet, even if you're not ordering your lumber that way, to get the amount of materials and stuff you need and things like that. Any other questions? Kind of to go back to this joist thing again. In construction, there's also, we talked about subtracting one if you don't need one on the end. It's actually not uncommon to not have a joist on the end of a run either. In some areas, building code requires that you cannot use a floor joist on your end walls. So you run joists across here this way, and they require to have hand frame or balloon framed end joists. And the reason is even if you order trusses are either 2.5 or 3.5 inches wide. In some places, building code requires a 6-inch end joist for energy efficiency for insulation. So those have to be hand framed. Anyway, any other questions off the homework? Okay. Well, let's start with our new stuff then. And what we're going to look at today, we're going to look at problems where we run into something like this. And when we look at a problem like this, some people might look at it, and which would make perfect sense, and say, I read a book from left to right. I'm just going to do my problem from left to right. So I'm going to do 7 plus 3 is 10. 10 times 8 is 80. Minus 5 is 75. And that does make perfect sense. The only problem is it's wrong. Different people could look at that problem and interpret it different ways. There's several different ways you can approach that problem, and they would all give you slightly different answers, sometimes radically different answers. And in math, we really kind of like to have two people do the same problem and get the same answer. So what they've defined is a set of rules called the order of operations. And what the order of operations does is it sets 4 different levels. Now, it doesn't necessarily, everybody thinks the order of operations means you have to do this first and this first and this. That's not really what it means. What it really is it's levels of priority. And it means if you can, this is what has the highest priority, so you try to do that first. Or it has a higher priority than what's below it, at least. The first item in our level of priority is enclosing symbols. Many of you have probably heard this as just parentheses. And parentheses is one kind of enclosing symbol, but there are several other enclosing symbols that we will run into. Second level of priority, exponents. Exponents include 2 things: powers and roots. Both of them are forms of an exponent. Third on our level of priority, now remember we said that they're really the same operation. So they're going to happen at the same time. Multiplication and division are the third level of priority. And finally, lowest priority, addition and subtraction are the last things that get done. Now, I should qualify. This order of operations only applies under certain conditions. And that main part of that condition is that there's nothing else, no other information given in the problem other than a list of numbers and operations like this. In most practical problems, there will be a situation behind the problem, and that situation will determine what order you're going to do those operations in, not just the numbers themselves. So this only applies when we have no other information to go off of. So here, what would happen first? Do we have any enclosing symbols? No, we do not. Do we have any exponents? No. Multiplication and division? Yes, we do, right here. So what we're going to do is we're going to take those two numbers that are involved in that multiplication and we're going to combine them. 3 times 8 is 24. Now we're going to replace the 3 times 8 with just the single number 24. We still have the 7 in the plus up front and the minus and the 5 in back. Now again, we have to double check, and we can do this part really quickly. There weren't any enclosing symbols before, so there's none now. No exponents. Any other multiplication and division? No. Addition and subtraction? Well, yes, there's one of each. If there's more, and of course addition and subtraction are at the same level. So if there's more than one thing at the same level, how do we determine which one to do first? Left to right. That's where the left to right comes in. So addition and subtraction would happen at the same time, but since they're both there, we're going to start on the left and go to the right. 7 plus 24 is 31. And then we would do the 31 minus 5 is 26. As you can see, that's slightly different than the 75. And have you guys talk me through this one. What do I have to do first here? The exponent. There are no enclosing symbols, but there is an exponent. 3 squared. That's going to be what? 9. So I'm going to replace 3 squared with 9. Everything else stays the same. Now what? Yep, I have 2 multiplications, the 7 times 5 and the 2 times 9. I'm going to go left to right. 7 times 5 is 35. Next, 2 times 9 is 18. And now, of course, all I have left to do, subtract. 35 minus 18, 17. Good. Any questions on that one? Let's have you guys try a simple one here. Let me try that one quick. I'll pause the recording for a minute and give you guys a chance to work. So we start with the exponent. Good. 2 squared, which is 4. Now you've noticed on each of these so far, I've been rewriting the whole problem at every step. I've found through the years that many of the mistakes students make on these is just rewriting the problem. So I'm going to show you a way that I cheat. What would be the next step that we do here? Divide. We have division and multiplication, which happen at the same time, so we go left to right. And the first thing that occurs left to right is the division. 28 divided by 4, which is 7. So here's how I cheat. So if you use pencil on your paper, you might get away with this. Otherwise, you may have to write out more. I'm just going to take the 28 divided by 7, and I'm going to erase it and replace it with, or 28 divided by 4, sorry, and replace it with 7. What's next? 3 times 5, which is 15. So I'm going to do the same thing. I'm just going to erase it and put in a 15. Now we're down to simply addition and subtraction. What do we do first? Left to right. 12 minus 7 is 5. Plus 15 is 20. So that comes out. How many you got 20 for that? Great. Let's look at one just a little bit more difficult. Bless you. Let's try that one, just a little bit more difficult. Some of you might not quite be done yet, but let's go ahead and give it a shot. Where do we start here? Well, do we have any enclosing symbols? Yes, we do. We have a couple sets. Remember, anytime we have more than one thing on the same level, we go left to right. Going left to right, this is the first parentheses you run into. So we have to find its mate. Its other end, in other words. Where's its other end at? After the plus 1, right there. So what that means is we have to start working inside that set of parentheses, or inside the green box. Now some of you might be like, well, but there's another one. Yeah. Inside that parentheses, inside the green box in this case, we still have to follow the order of operations. And inside there is another enclosing symbol. Right there. So now we're going to narrow down our work inside the purple box. So what do we do first there? Okay, yeah, we go through the checklist. Any other enclosing symbols? Not inside there, no. So exponents, the 5 squared, which is 25. And of course, technically we rewrite everything else. Now I'm going to start cheating again and just erasing and replacing here. Still inside that purple box, inside that enclosing symbol, what's next? Got 25 minus 19, which is 6. So I'm just going to erase it and replace it with a 6. Once we've reduced what's inside a set of enclosing symbols to a single number, we don't need the enclosing symbol anymore. We can get rid of the enclosing symbol. Now with the parentheses, there's nothing else to do other than just get rid of the parentheses. So I can take out the parentheses. Only in this case, there's a little hitched little thing that we have to put in here. Can anybody tell me what it is? Yeah, we had a 3 in front of the parentheses there. Anytime you have a number on the outside of a parentheses with no symbol between it and the parentheses, it implies multiplication. That's 3 times whatever's in the parentheses. So when we take that parentheses out, we have to make sure we put in multiplication there. That's 3 times that 6. Now we can go back out to the larger set of parentheses. We're done with that set of parentheses. Inside that yellow box, now the big parentheses, are there any other enclosing symbols to worry about? No. Any other exponents? No. Any multiplication or division? Yes, in fact, we have a couple. And once again, we go left to right. So we're going to start on 18 divided by 6, which will be 3. So I'm going to erase that and replace it with a 3. What's next? Multiplication. 3 times 6, which is 18. So I'm going to erase that and replace it with an 18. Now what? So we have addition and subtraction still inside the parentheses or inside the yellow box. What do we do first? Left to right. 7 minus 3, which is 4. And then 4 plus 18, which is 22. And then 22 plus 1, 23. So now I've reduced that set of parentheses to a single number. So what do? I take them out, and I have to remember to put in multiplication there. Now what? We multiply. 3 times 23 is all this stuff. There's no other enclosing symbols, no other exponents. So 3 times 23, which is 69. And then 6 and 69 is 75. And then 75 minus 7 is 68. So all that becomes 68. Now I hesitate to tell this part to you because I don't want to draw your attention to it and push you to do it. But I have to bring it up. The single biggest mistake I will see made, and I will catch probably close to half of you with this on the first quiz that I give, on a problem like this, will be this right here. Oh, I got 6 plus 3 up front. Let's just add that to make 9. And I know you'll smile a little bit, but I will catch a good portion of you doing that on our first quiz. So be very careful. Why can I not add the 6 and the 3? Because the 3 is multiplying something here. And this multiplication has to happen before that addition. And in order to get to that multiplication, of course, we've got to get all this done first. But when you look at a number, there's an operation on each side of it. And you got to figure out which operation must happen first. And for that 3, it can't do anything until it takes care of that multiplication. So be careful with those. Now let's look at some that are a slightly different form. So let's look at this one. To understand this problem here, first thing we have to understand is this symbol across here, that line. What does it mean? Okay, most people say divide. It's what we call a fraction bar. And it does mean that we're going to divide something, but it means a lot more too. It is actually an enclosing symbol. An enclosing symbol is anything that separates part of the problem from another part of the problem. It is telling us that we have to do everything on top first. And then we have to do everything on bottom. Then we have to divide. So on the top of this, I'm just going to rewrite it over here. What do we have to do first? 3 times 9 is 27. And then 4 times 3 is 12. And 27 minus 12 is 15. So the top of this reduces to 15. Then what do? Okay, so on bottom, we have to do the power first, the exponent first. 4 squared is 16. And then multiply. 3 times 6 is, not everybody at once, plenty of time for everyone to participate. 18, there we go. And then add what? 18 plus 3 is 21. Minus 16 is 5. So the bottom reduces to 5. Are we done? Almost. What do we do next? 15 divided by 5 is 3. I want you guys to try one of those. Give that one a shot. Okay, now on something like this, I realize I kind of threw you under the bus a little bit by not showing you this type first. But it's really two separate problems that are combined into one. We're going to do this whole piece first. And of course there, what do we have to do first? The top. 8 plus 11 is 19. Then we have to do the bottom. What are we going to do first there? Multiply. 3 times 6 is 18, and then 1 plus 18 is 19. So that one is 19 over 19, which is 1. Over here, what are we going to do first? We're going to multiply. 5 times 2, 30. On bottom, 7 times 5 is 35. I'm going to take a little shortcut. 8 times 4 is 32, and then subtract to get 3, okay? 30 divided by 3 is 10. So this part became 1, this part became 10, and we still have to add them. 1 plus 10 is 11. Perfect. How many of you had that one? Where would you use that one? There's some engineering formulas you would use it in. Really, basic carpentry, not so much. You got to remember, I'm an engineering geek, so I have used a lot of this stuff, but I may or may not be totally normal. Also, being someone who likes math as an engineer, you can always find places to use the math instead. I mean, I used to do a lot of calculations that I didn't have to because I could do it quicker by hand than what most people could enter the information in the computer. So anyway, the last one I want to show you is this. Gotta be careful here. I'm just going to have you guys talk me through this one. Where do I start here? Inside the square root. That is it. It's two things there. It is an exponent, but it's also an enclosing symbol. It's basically saying we got to do everything inside of it first. So inside there, what do we have to do first? 8 squared, the exponent. 64. Then what? 13 times 5, which is 65. And then what? Subtract. 65 minus 64 is 1. Now, I didn't make this a very interesting piece here. But just like any other enclosing symbol, that square root, once it's down to a single number, we can get rid of the enclosing symbol. The difference is in a parentheses, once it's down to a single number, you just get rid of the parentheses. For a square root or some other enclosing symbols, once you're down to that single number, you get rid of it by performing an operation. Now here it's not much of an operation. What is the square root of 1? 1. So we take away the square root by finding the square root of 1, and that symbol is now gone. Just like any other enclosing symbol, what do we have to do here between the 3 and the 1? It is multiply. Anytime there's a number outside an enclosing symbol with no symbol, it is multiplication. So now 3 times 1 is 3, and 9 plus 3 is 12. Any questions? Okay. What do you think? Yeah, if it were something like this, take the square root of 25, it would be 5. Then it's 7 times 5 or whatever. Yep. Okay, homework for you. There's going to be 2 pieces here. In the little book, it's going to be Unit 5. Unit 5 talks about these combined operations. Now, this is what I told you at the beginning. There's a situation that tells you what order to do the operations in. Not necessarily the order of operations anymore, but there's going to be these are all word problems. There's a situation with most of the problems that tell you what you have to do first. So then for practice in the big book, on page 24, it is exercise 1-11, problems 1 through 33, the odds. Now, once again, this is the odd-numbered problems here in Unit 5 as well. Once again, I assign the odd-numbered problems because the answers to the odds are in the back of the book. Also, with these in the big book, 1 through 33, I realize that's 17 problems. If you do one or two of the first ones and they're really easy, and the first couple are really easy, feel free to skip ahead to some of the more difficult ones and go from there. A couple of the middle, a couple of the end, yeah. Just kind of look around, and if you see some that look different, make sure you hit the different ones. I'm not going to collect these and grade them, but I give you so many problems for homework so that if you are struggling, you do have enough that you can keep practicing and get better at them. But again, I will never collect this and grade it, but do enough of them that if a quiz happens to come up, like say Thursday or so, or tomorrow, one of the two, you're prepared for a quiz. For those of you following along at home, that may have been a little foreshadowing there, yes. So anyway, you have the last couple minutes to get started on your homework. I'll answer any questions for you if you need me to.